All right, so so a couple of things here. So first of all, arc sine and inverse sine of x are synonymous. So these mean the same thing. It's for all of them too. You know, it could be arc cosine is inverse cosine. Now, just to remind you what this represents, and they're all the same. Okay, arc tangent and inverse tangent. Now, the representation of this means your input, so if this was a function, y equals inverse tangent of x, the way it works is your input is an x, which is a ratio, and it finds an angle in radians. So for instance, if I had inverse tangent of 1, it's asking me tangent of what angle is 1. Let's see if you can remember this from pre-cal. Can you take a guess as to what angle the tangent is 1? It comes from one of the special triangles. Pi over 4. It's 45 degrees, but he answered it correct. The answer is pi over 4 because it needs to be in radians, but it's 45 degrees. So if you look at a 45, 45, 90 triangle, again, on the work backwards of it, right? Tangent of 45 is 1. So if we said, what does inverse tangent of 1 equal? You're working backwards and finding the angle. So just to make sure you understand what these inverse functions give. You plug in the ratio, it gives you the angle. So for instance, if I had inverse sine of square root of 3 over 2, again, there's a ratio. So it's asking sine of what angle is square root of 3 over 2? And it wants the answer in radians. All right, anybody want to take a guess? So that comes from your other special triangle. 30, 60, 90. Across from 30 is 1, across from 60 is square root of 3, across from 90 is 2. So let's see, sine of 30 is 1/2. That's not right. Sine of 60 square root of 3 over 2. So it's a 60-degree angle. And the radian measure for a 60-degree angle is pi over 3. Okay, so I'm just giving you the gist of what these functions give you. Because if you get a definite integral and you have limits, then you got to handle those limits. Okay, which we can talk about in a second. You know, how would we do that? Now, at the quadrant angles might be a little tougher. So if you said inverse sine of what angle is 1, that one is 90 degrees because that comes from the unit circle. Because on the unit circle, the y coordinate is 1. That's at a 90-degree angle, so that would be 90 or pi over 2. So we'll have to look and see, just in case we get some with limits. So I'll talk about that in just a second. I'm still trying to cover how you would handle all of your indefinite integrals. So here's the case that we could get. I'm going to erase this. The situation we could get if where you're going to be like, well, how do I attack this? What do I do? So let's say we've got the integral of, say, 1 over x squared plus 6x. Now, so you can see that the problem is it doesn't, if I'm going to guess as to one of the three, arc sine, arc cosine, or arc sine, arc tangent, arc secant, which one would you say it's the closest to? Tangent, because there's no square root, right? So this is an arctangent, and we will use arctangent to do this. The problem is it's not in the form. So to do arctangent, it needs to be in the form u prime over a squared plus u squared, right? And then it's dx. So we need a function squared and we need a constant squared. But we have a function and another x. So what we've got to do on this is change this form. Okay, you cannot have that form. This is not going to work. What am I doing wrong? Let me think. Why is that not going to work? That won't work because I'll get a minus. I may have to just steal one from the book, sorry. Give me just a second. I'll show you, I'll explain, it's not gonna work, just give me 1 second here. All right, this one will work. Let's just add a 13 to it, sorry, that will work. Okay, sorry, just change it to that. And then I'll show you, yeah. Okay, there we go, so make a plus 13 on it. Not gonna change, yeah, this will work. Okay, so the problem is that I don't have a constant squared and a function of x squared. So what we're going to do is we're going to change the denominator into what's called a perfect square trinomial. For instance, if I had x squared plus 2x plus 1, that would factor x plus 1 times x plus 1, because there's two numbers that multiply to give 1, add to give 2, and that becomes x plus 1 squared. Hence, my function of x squared. So if I had x squared plus 4x plus, let's think what the last number needs to be. All right, so let's think, because I wanted to go x, and I want the same number. So what two numbers multiply to give a number and add to give 4? They have to be the same number. What two numbers multiply to give a number and add to give 4? 2. So 2 squared is 4. Let's see. Does that make sense? Will this factor to this? Let's see. Right? Because what do you need? Two numbers that multiply to give 4 and add to give 4. Two numbers that multiply to give 1 and add to give 2. That's how we factor. That's the question we ask. So yes, this factors to this. This is why this is special. This is called a perfect square trinomial. And so what's perfect about it is that when you go to factor it, you get the same factor twice. And then that's written x plus 2 squared. All right? Now let's just keep going with even. Even numbers are easier. If the middle number is even, it makes it easier to work with. Let's think. So look at the pattern. The last number is half of the middle number, okay, but also squared. You don't see that part. Half of 4 is 2, 2 squared is 4. What's half of 6? 3, 3 squared is 9. So this needs to be a 9. Let's see if that makes sense. Are there two numbers that multiply to give 9 and add to give 6? What are they? 3 and 3. Now this is a perfect square trinomial, and now, oops. So it factors to this, which is x plus 3 quantity squared. So the rule is if I have x squared plus bx, the last number is b over 2 quantity squared. Half of the middle number squared. That's how you know to get a PST. Perfect square trinomial. Okay? So you're going to say, well, why do I want to write that? Because I got to get it to match to arctangent or arcsine or whatever. I need a function squared. So I need something squared. So I need to change this into this, okay? So now let's go to our problem. So we need a function squared and we need a constant squared. So we'll worry about that. Now let's go to this. I don't want that to be a 13. Since that's a 6, we want the last number to be what? 9. So we're going to make it a 9. So here's what's nice. 9 is part of 13. So all we're going to do, we're going to say x squared plus 6x, and I'm going to break the 13 up into two numbers. So instead of saying plus 13, I'm going to say plus 9 plus what else? 4. Now, how do I know to choose 9? Because I want that to be a perfect square trinomial. Okay? See, now this is a perfect square trinomial. Remember, I need also a plus a constant. Now, these are out of order. I'll switch to order in a second, but it doesn't matter. So then now I know that this is the same factor squared, so it can be written x plus 3 quantity squared plus 4. Now, of course, I should change the order and write it 1 over 4 plus x plus 3 quantity squared, okay? So I changed the order on it here, and so that way it's it matches there. It doesn't matter. These are synonymous. As long as you know that this is your u squared and this is your a squared. Doesn't matter. And that's it. So you've got to know what the perfect square trinomials are. So now you're going to say, well, how would I work it? Well, a squared, I would list everything. What's my a squared? What's my u squared? So let's go through it. What's a squared? 4. What's a? 2. What's u squared? X plus 3 squared. See, this is where it becomes easy. So what's u? X plus 3. So what's u prime? 1. See, it matches. All I had to do was rearrange the bottom. And now, that's it. Now you know the antiderivative. 1 over a arctangent of u, which is x plus 3 over a, which is 2, plus c. So there you go. Okay? So let's list some more perfect square trinomials before we stop here. Now, if it's a minus in the middle, you would still put a plus on the end. So for instance, a minus doesn't bother us. So let's say we had x squared minus 2x, it would still be plus 1, but that would be x minus 1 squared, if you think about it, right? Because two numbers that multiply to give 1, but add to give negative 2, you just put a minus. So if it was x squared minus 4x, it'd still be plus 4, x minus 2 squared. All right, x squared minus 6x plus 9, x minus 3 squared. All right, what would be the next one? So we go x squared minus 8x. What should the last number be? 16. That's exactly right. Half the middle number squared, and then that's x minus 4 squared. Okay? If it's x squared minus 10x, what should be the last number? 25. See, we're just taking half the middle number and squaring it, and then that would be x minus 5 squared. Okay? Got it? All right, so let's try another one. Okay. So now you've got, I've listed some of these, and those are with minus. If it's plus, then it's all plus. All right, so let's save those there. Yeah, those are showing up.
So factoring the denominator will only work if it's a perfect square trinomial.
What's that now?
Factoring the denominator will only work if it's a perfect square trinomial.
Well, you want it to be, your goal is to make it a perfect square trinomial so you get something squared. Because you need that u squared. Otherwise, you can't match it to arcsine, arctangent. Okay? The arcsines are a little bit tougher. Let me see if I can find one more. All right, try this one, and then we'll do one more type, and I'll show you. So again, what tells me it's probably arctangent? See, it's not u prime over u. I would need an x up here. See, I'm short of x. So the u prime over u is not going to work. See if you can do that one. What probably can be taken out of the problem? All right. I just threw it in there. Okay, let me just a second, get this. All right. So, let's look at this. So it's the 2. I need the last number to be a what? A 1. So I'm just gonna break this up. I'm gonna go ahead and take the 5 out. If we make the last number a 1, we do just plus 1 plus 1. Here is our perfect square trinomial. So it becomes, oops, 5 is on the outside, x plus 1 squared plus 1. So you can see it fits the form of u prime over a squared plus u squared. Now obviously my a squared and u squared are switched, okay? But then there you go. You can go and finish the problem now, okay? And from there, I think once you get to this part, I can stop because I think you know what everything is, okay? Now here's where they can get a little trickier, trying to find one rather than me trying to make one up. Okay, this should work. Okay. So now I see the square root. All right. So again, integrate. And what we're trying to do, we've got to make this problem u prime over the square root of a squared minus u squared. So again, that needs to be a function of x squared. We're going to try to make it into a perfect square trinomial. But now notice that there's the minus. So this is where this one gets a little tricky. So let's just go out of the square root for a second and manipulate this. As long as we remain equivalent, we haven't changed the problem, right? For instance, what I mean, we remain equivalent, we change the 2 into 1 plus 1. So what we've done is change the look so it matches to the formula. We haven't changed the problem, okay? So here, this one now is a little different because of the minus in front. So I'm going to come out to the side and show you how we work this. Now notice, we don't, on all of these, we don't want a coefficient of x. See, we don't want anything in front, okay? So the first thing I'm going to do is if there is a minus, I'm going to just factor the minus out of this. Just put it in front and put parentheses and only work in the parentheses. So if I have a minus, I factor it, and now I work in the parentheses. And my goal is going to be to make this in here a perfect square trinomial, okay? Now, once I make it, then I will show you what we'll have to do. Okay, so now, this was the type I was trying to do earlier, but it wasn't going to work. So, now you can see there's no other number. So I have to put it there. I have to put what I want, but I also have to keep the problem balanced. So you can always add 0. What I mean by that is I can add 2 and subtract 2. I can add 4 and subtract 4. I can add 9, subtract 9. You know, whatever I need to do to make it a perfect square trinomial. So, if it's a minus 4x, what would I like this last number to be? Plus 4. So what I can do in here, you've got 2 ways to look at this. You can put a plus 4, I've got 2 ways to explain this. I'll show you both ways, if that, we'll see. But I can't just put a plus 4 because it needs to remain equivalent to this. I got to put a minus 4 also. Okay? Now, this is where it's hard for me to kind of make sure that I explain this right. Okay, I only want what in the parentheses? What do I only want in there? Yeah, only the first 3. I don't want the minus 4. So what I'm going to do is I'm going to separate it now. I'm going to just have this, and I'm just going to have this outside of it, because I don't want it in here. I want this inside, so I can just change it to x minus 2 squared. So here's how I'm going to do that. I'm just going to break this up. The minus goes with this, and the minus goes with the minus 4. So I'll do minus with this, and I do minus with the minus 4. That makes that a plus 4. Hope that you can see that there. Yeah, put the minus with these 3 is in front. Then that minus goes to that minus 4, makes it a plus 4. This is where it's a little tricky. That step is going to be the tough step there. Why did I do this? Because I only need 3 terms, so that now I can write it as, so now I can change this into what? It becomes what?
Minus x.
Or x,
X squared minus, or minus 4.
no.
Minus.
Yeah, if it's x squared minus 4, x plus 4 becomes x minus 2 squared, and then I have the plus 4. And notice I need a plus 4 because I need that positive constant, see? That's gonna go in front here. So that's where this is tricky. So once you add your 0, I would then break my problem up. The first 3, put the negative in front of these 3, then that negative goes there and just bring that part outside, okay? All right, and then we get 2 over square root, that's 4 minus x minus 2 squared. And now you'll notice that this matches arc sine perfectly. Okay, except probably I'll take the 2 out. So then see if you can finish this up. It should match the arc sine formula. So arc sine of u over a plus c. I think I'm Zooming with them tomorrow. You got an email from me yesterday, right? It should say Zoom is tomorrow, not today, I believe. Confirm. Okay. Let's see if we can list everything. I'm going to take this 2 out. So a squared is what? 4. So a is, u squared is what?
X minus 1 squared.
Yeah, then it becomes easy. So u is what? So u prime is what?
1.
It's all about rewriting it. Once you rewrite it, you really have, now it matches it perfectly. So our answer is just arc sine, oh, I got a 2 in front, sorry. U over a, u is x minus 2, and my a is 2. Let's see. All right. Now, so one last thing before we stop on this. I'll give you one more, see if you can manipulate it, okay? Try this one. Try, let's say you had this under a square root. I'm not even worried about the square root, I'm just worried about the completing the square. So see if you could change this. Yeah, see if you can change that to fit this. And then I want to show you one last thing. Remember, factor that minus out first. And then change the inside parentheses to a perfect square trinomial. let's have a look. So I'm gonna change that. First thing I'm gonna do is take the negative out. That leaves me with x squared minus 8x. All right. Then I'm gonna think, what do I want with the 8 at the end? I want a what? Plus 16. So I put a plus 16 and a minus 16 so that I'm adding 0. Now I'll group the minus with the first 3, so that minus goes there, and then I'll distribute the minus to the negative 16 on the end. That gives me a plus 16. Yeah. And then I can bring this 16 in front, and this changes to a perfect square trinomial, or it factors x minus 4 squared. So now this becomes 16 times minus, see the minus is there, and this in here becomes x minus 4 quantity squared. So we get 1 over the square root of 16 minus x minus 4 quantity squared. Okay. All right, you can follow the steps there. You can, so the negative went to the first 3, and then negative goes to that plus 16 to get it, to that minus 16 to get it. Now, just take the last thing I want to do is limits. All right, just what if I have a limit? So like, let's say I have this, and our problem is this one. I'm doing the most basic arc sine problem. So I'm not worried about the integration. I just want to talk about how you work with the limits. So our antiderivative of this is just arc sine of x. And then it's 0 to 1. So you know from fundamental theorem of calculus, you got to plug that 1 and 0 in. But the question for you is, how do you work this out? So again, this is asking sine of what angle gives us 1, sine of what angle gives us 0. It's not very common ratios that we're thinking of, like the 1 over square root of 2 or square root of 3 over 2 and all that. So these are not from special triangles. So you've got 2 ways. If you want to use your calculator, I would probably go into degree mode just so I can get the angle in degrees, then I can change it to radians. And then you just do inverse sine and plug those in, and you'll get the degrees. And then we'll change it back to radians. So you can type both of those in, just use your inverse sine button, and that will give you both of them. Anytime I get 1, 0, or negative 1 on an inverse sine or an inverse cosine, it's angles that land on an axis. See, so I go back to the unit circle. This is probably something good to have memorized. So now I'm working backwards on the unit circle. The way the unit circle works, it tells me the sine and cosine of each of these angles. So for instance, at 0 degrees, I know that the cosine of 0 degrees is 1, because the coordinates, the x is always the cosine of the angle, the y is always the sine of the angle. So sine of 0 degrees is 0. All right. Here, cosine of 90 degrees is 0 because it's the x. Sine of 90 degrees is 1 because that's the y. So now this is asking sine of what angle is 1? That would be 90. Then I'm working backwards. So that's 90, but we got to give our answers in radians, so that would be pi over 2. So this is pi over 2. Minus sine of what angle is 0? Sine of what angle is 0? Yeah, I'm working backwards. So this is this 0, so my angle is 0. Pi over 2 minus 0, and we get pi over 2 for the answer. All right, so it's not the easiest, but you can input those on your calculator, and it will give you the angle. What I would do is, if I get the angle in degrees, I would convert it to radians. You can't give degrees, because why can I not put 90 degrees as my answer to this problem? Because if I had put 90 instead of pi over 2, I would get 90 degrees. Why can I not put 90 degrees? Because it's net area. Don't forget what definite integrals are. This is net area. This is area under a curve. You can't say degrees for area under a curve. You just got to give a number, a value. And this value is pi over 2. Okay? All right, that should get you pretty good working, and then what we'll do is we'll look to answer questions tomorrow, okay?